Okay, as in the previous questions, whenever I can, I start out and at least check to see if I can do a direct substitution. Just meaning, can I just plug in 5 into the expression as is? So I would have square root of 5 minus 1 minus 2 over 5 minus 5, and we can kind of already start to see that's going to be a problem. So that's going to be the square root of 4 minus 2 over 0, which ends up being 0 over 0 again. So we don't know anything about it at this point. We do need to go ahead and use some kind of an algebraic approach. So if you remember, our algebraic approach was one that we said we had to actually then multiply by whatever would create a difference of squares in the numerator. So that essentially just ends up being exactly the same thing that's in the numerator. You just change the sign in between the terms. So instead of being minus 2, it becomes plus 2. And at that point, you go ahead and you multiply everything out. So the limit as x approaches 5 of. So the whole point in making a difference of squares, remember, a difference of squares, something like x minus 2 times x plus 2. When you multiply that all out, you get x squared minus 2x plus 2x minus 4. These middle terms are always going to be 0. So really, all we had to do here was we had to multiply the first terms together to get x squared, and then the last terms together to get minus 4. So that's what I'm going to do here. I'm going to multiply these two terms together, and then I'm going to multiply these two terms together. And that's going to be my product. So when I multiply x, the square root of x minus 1 times itself, it's just x minus 1. When I multiply negative 2 times positive 2, I get minus 4. And that's going to be all over. Now, remember, in the video and when we did this initially, we talked about not actually multiplying out the denominator. So I'm just going to leave it like this. Okay, and then I can go ahead and simplify the numerator. So I've got the limit as x approaches 5 of, so that's going to be x minus 5 in the numerator all over x minus 5. Ooh, that's nice. That's what we want. Okay, and then I've got my giant 1 right there, which allows me to simplify this a little bit more. So I've got the limit as x approaches 5 of 1 over the square root of x minus 1 plus 2. Now I can do my substitution where I can plug in 5 for x. Okay, so I'm going to get 1 over the square root of 5 minus 1 plus 2. That's the square root of 4 plus 2. 2 plus 2, which is actually just 1/4. Again, this is our exact value, and that's what the problem asks for. If I wanted an approximation, then you could use your graph or a table to make an educated guess, but this gives us an exact value.